All right, so this will be the third lecture for calculus 2 integral calculus. We're going to continue now integration of transcendental functions. Particularly in this lecture, we're going to be dealing with exponential functions. Previously, uh, we did logarithmic functions or integrals yielding logarithmic functions. This time by integration of exponential functions. Okay. All right. So for this particular discussion, we have these two important formulas, similar with your derivatives of exponential functions, right? You also have two formulas. Isa for base E exponential functions, okay, and then isa is for base A exponential functions, okay, where A can be any arbitrary number that's greater than zero, okay, this will be positive, and A cannot be equal to one, all right, so it could be fraction of some sort, or isa um real number that's greater than zero and not equal to one, okay. So those are exponential functions. Now the formula is also very straightforward, given than some derivatives. Integral of e raised to u du. Before we can use this formula, alam natin that we must first check that u, ang exponent of our function. Okay? If we differentiate the exponent of our function, dapat palabas yung remaining term in the integral. Okay? Similarly with base A, all right, we still have, before we can use this formula, we still need to check whether the derivative of the exponent is actually the remaining term. So, bakit yung ginagawa natin? So, for example, u over u, right, we still have to check first kung yung denominator, if you differentiate the denominator, yung numerator ba yung lalabas. Okay, so ganito yung gagawin natin dito. Alright, let's start. Okay, I'm not going to give you any more sample problems because this one is more straightforward. And given that you have already background of direct questions from our past discussions, I guess you can already get a feel and you can already determine what's actually happening in each of these sample problems. Okay, so number one, we have here integral of y e raised to y squared plus 4 y. Okay, so immediately you can already see sa function natin, sa integral natin, our function contains an exponential function, particularly base e exponential function. Okay, so ibig sabihin, we're probably most definitely going to use this formula. E raised to u plus, that's it. Okay, now, our problem again, before we can use this formula, is to check if our exponent value, derivative for exponent, is actually the remaining function. Okay? Before we do that, let's rewrite muna the entire function. Para mas malinaw siya, we can rewrite this as e raised to y squared plus 4. Okay? And then y. Kasi yan yung separation. Okay? Alright. Now we can do our u substitution. Let u be equal to, from our formula, our u is our exponent, okay, in the exponential function. So definitely in this particular example, u is y squared plus 4. Okay, now let's determine what's the derivative of that u function. Okay, so what's the derivative of y squared? It's 2y plus 0, okay, d1. Okay, now let's check. Okay, yung u ba natin is perfect? Yes, of course. Okay, no problem or good. Next. Okay? However, yung du natin, to compare to our function, kulang siya ng, okay, but apparently we know what to do kapag nagkukulang ng function. We integrate the use of, or we use integration factors. Okay, so 1/2, that'll be this reciprocal of 1/2 integral of, now we can rewrite this as EU. Okay, upon checking. It's exactly EU. Ito, this function is exactly e raised to du except for the fact na nawawala yun. Okay, so therefore we can rewrite that as EU. Okay, and evaluating this integral from the formula, ang sabi dyan ay 1/2 a raised to u plus c. Okay, or essentially 1/2, bringing it back to its algebraic expression, y squared plus 4 plus c. Okay, that'll be your answer for this particular example. Okay. Again, if you have confusions, clarity, you can just go back, right? Number two, let's move on. Okay, so we have here trigonometric functions, right? We're also going to discuss the sabi ko previously. Trigonometric functions are also transcendental functions. So to begin, we're going to have, after this actually, we're going to have a discussion of integrals of trigonometric functions. Okay, so let's see. If nandito to, ibig sabihin we don't necessarily need those formulas yet. Okay, so this is probably derivatives. Okay, so right at the back again, nakita natin, there is an exponential function. And there is an exponential function. And you might argue, sir, that's also a fraction or a quotient. So maybe that will give us or that will yield um, ln. Okay? But upon investigation, you can already, that's actually impossible. Kasi your denominator is cosine squared x. There's no way na pag differentiate natin, ang lalabas, di ba? There's no way na pag differentiate natin, and it will be remotely close to e raised to tan x. Not possible. Okay? So, tanggalin na natin yung idea of yielding ln. Okay? What else do we have here? We also have an exponential e tan x dx. Okay? So, let's evaluate using our exponential function formula. Okay? And let u be equal to, again, diba? So, e raised to u du, e raised to u plus. Okay? U again is the exponent, which is tan x. Okay? Now, what's next? We need now to evaluate the derivative of tan x. I hope you remember your derivatives. Okay? Dahil wala kayo, I guess I have to answer this. Derivative of tan x is secant squared x dx. Okay? Now, compare natin doon sa original function natin. Okay? Tan x is actually u, perfect, kasi diba sabi natin that's exponent. Okay? The remaining function dito, sulat natin dito. So e raised to tan x dx all over cosine squared x. If this part is your e raised to u, therefore this part is your du. Okay, as is equals to dx all over cosine squared x. Okay? I hope you're with me. Okay, ito na yung remaining na function, di ba? Kasi e raised to tan is already your eu, e raised to u, right? So ibig sabihin dx over cosine squared x is your du. Okay? But apparently, upon investigation, sabi natin, what we expect to find is secant squared x dx. Pero ang meron tayo ay dx over cosine squared x. So I hope you can already see where I'm going. Kasi this one can also be written as 1 over cosine squared x, and by your reciprocal identities, right? That is also secant squared x dx. I hope you haven't forgotten your identities right after this one. You will leave them still here. Okay? So that means we don't have any problem at all kasi yung u natin is exactly perfect from our integrand, and our du is also equivalent with that. Diba? So sabihin, nothing's missing, nothing's problematic. And so therefore, we can rewrite our example here or our problem here as e raised to u du, clear and simple. Okay, and according to the formula, ano lalabas dyan? E raised to u plus c. Which, when we return it back to its original form, what is u? U is tan x, tan x plus c. Okay, that's it. Right? Very straightforward. You just need to be, you just need to have sharp eyes to be able to see between the functions, I guess. All right. Okay, moving forward. All right, so we have here e raised to x plus 1 squared dx all over e raised to x. Okay? Again, mag-iisip na naman tayo ulit anong pwede natin gawin dito. As you can see, isa lang yung term sa ilalim. Right? So, isa lang yung term sa ilalim. And if we can expand the numerator and divide every term of the numerator to e raised to x, then problem is solved. Diba? Let's do that. So yung numerator natin is essentially e raised to x plus 1 multiplied by another e raised to x plus 1 dx all over e raised to x. Okay? Or lagyan na lang natin ng para mas malinaw. Okay? Expanding the numerator, that will be equal to e raised to 2x, right? I hope you're with me. Tapos dalawang e raised to x, so that's 2 e raised to x plus 1. Okay, I hope you're with me. All over e raised to x divided by, sorry, multiplied by dx. Okay, so you can already see how to solve this, diba? Napakadali lang. So, integral of, isa-isayin natin para mas malinaw. E raised to 2x over e raised to x dx plus integral of 2 e raised to x all over e raised to x plus kasi integral again, sorry, may dx dapat to, dx. Okay? 1 dx. Okay? 1 ba? We can evaluate this. Hindi pa pala. Simplify pa natin para mas malinaw. Right? Let's simplify further. That would be e raised to x na lang sa taas. Right? Magka-cancel na. Plus 2 integral of dx na lang. Right? Magka-cancel na yung e raised to x. Plus integral of dx. Okay? Which ultimately should give us the answer. Integral of e raised to x dx. Diba? That's essentially e raised to your du. So that's e raised to x. Okay? Plus 2 times integral of dx, that's x. Okay? Plus x. Yeah, plus c. I'm wondering if I made a mistake here. Did I? I see. This one. Kasi it's a little bit weird na magsasama sila sa dulo. Like they're the same term. 2x plus x. Okay? So upon reviewing, eto siya. Kita natin ang mali dito. This should be 1 over e raised to x. 1 over e raised to x. Okay? So kita. Okay? This should be 1 over e raised to x. Okay? So this should be, ayun natin ito. Ayun, ganyan. And this is also wrong. Okay? This should be apparently dx over e raised to x. Papalitan na rin natin yan ng, itaas na natin siya, ng e raised to negative x dx. Okay. Okay? And if we get the integral of e raised to negative e raised to x, yan ay negative, negative, di ba? Integral of e raised to negative x dx. Okay? So, your u is negative x, your du is negative 1 dx. Okay? Ang problema, nawawala yung negative 1 nyo. Okay? Nawawala yung negative 1 nyo. Kaya mag-multiply kayo ngayon ng negative 1. Sulat natin maayos. Hanggang na natin i-value. Tuloy natin ang maayos. Okay? This will be integral of e raised to x dx plus integral of dx plus integral of e raised to negative x dx. Okay? Now, pwede na natin itong sagutan na this is e raised to x, right? Plus 2x minus e raised to negative x plus. The reason why may negative dito is because of this one. Okay, diba? Negative times negative, positive. Okay, so ika-cancel out sila. In case dumating yung negative 1, magpakita yung negative 1. And ano ba reciprocal ng negative ng 1? So it's 1 by 1 over 1. So you don't really need to get them. Okay, so that's for number 3. If that's clear, you can just review what happened. Okay. Number 4. Is this the last item? And number 5. Okay. Number 4. Notice we're moving on to the next. We're moving on to the next formula now. Wherein we're going to use base A. Okay, base A na tayo. The base A natin na formula is integral of A raised to U du. Okay. Again, we still need to check whether the exponent, if the derivative of the exponent is the remaining term. Okay, so we copy the given over ln of A plus. Okay, so that's our formula. Now, ito very straightforward, diba? 5 is the base, And so therefore, our u is x plus. Okay, let's find the derivative of x plus 2. That's 1 dx. Okay, now let's check. Perfect. And another perfect. Nice. So ibig sabihin, we're just going to follow the formula. Walang kahit anong complication, kahit anong kulang or something missing constant. Okay? Follow the formula as it is. That would be a u or all over ln of a plus c. A being 5. 5x plus 2 all over ln of 5 plus c. Ano ba? Very straightforward. Ganun ba? Okay? I just need to master how to do u substitution. Okay? Okay. Next up, number 5. What's this? Integral of 4e raised to 3 ln x dx. So it's back again on base e exponential function. Okay, let's do that. Okay. Right off the bat, nakita natin yung 4 dyan. Okay, yung 4 dyan, ilalabas natin kagad. Of course, nasa constant, diba? Lagi natin sinasabi. Constant yan. Ooh, I know what happens here. Okay? So, pag ginawa natin, pag we interpret this as it is. Okay? So, say for example, lagyan natin sa gilid. Kasi, hindi naman tamang solution. So if we try to interpret this as it is, notice that if we let u equal to 3 ln x. Okay, so what's the derivative of that? That's 3 times 1 over x. Diba? Or du is 3 over x. dx. Okay. And notice, dx lang ang nakalagay. Okay? Walang x. At wala rin yung 3. Okay, so di naman natin pwede yung gamitan ng iterating factor. Okay, kasi constants lang ang pwedeng gamitan ng integrating factor. In this case, an entire function is missing, which is an x variable. Okay, so ibig sabihin, hindi natin ito pwede gawin. Alright? So what we can do here is go back to the properties of logarithmic functions. Okay? And one of those properties, I hope you remember that, k ln of f of x is also equivalent to ln of f of x raised to k. And that's one of the properties. Diba yung mga properties then is ln of f of x times g of x can also be evaluated as ln of f of x times ln of g of x. Diba? Yan yung mga fundamental properties ng logarithmic functions. Okay, similar with quotient, sum, difference, and so forth. But there's also this property, okay, where k is a constant. So that means if we apply that property here, okay, we can rewrite this function as e raised to ln of x cubed x. Okay, e raised to ln of x cubed dx. Why do we have to do that? Because now we can cancel e and n. Okay, and so therefore we're going to be left with the integral of x cubed dx. Okay, and this one is very straightforward. Alam natin yung pansagutan yan. 4 multiplied by x raised to 4 all over 4 plus, or simply x raised to 4 plus. Okay, done. All right, so we have here another set of exercises for you to solve in the exercise book. Napakadami na nating exercises. I don't know how we're going to check them. Okay, but one thing's for sure, if you answer them diligently and honestly, it will help you a lot in the exams. I can tell you that. Okay, all right, so that's it for this lecture. Thanks for listening.